Other than sysinstall and ifconfig, there are many other tools available in Unix to manage all of these network connections. And there are several tools we're going to talk about, and a few we're actually going to demonstrate to you. Tools like netstack, dig, arp, route, ping, and traceroute are all available to you to help you configure, manage, and troubleshoot your network connectivity with your BSD box and the network. A lot of these utilities are universal and they're cross-platform. You will see some of these same utilities on Windows, Linux, and Mac. You'll see netstat on Windows just like you'll see it on Mac, just like you'll see it on BSD. The same thing with dig, arp, route, ping. One exception is traceroute. You'll see it actually called tracert on Windows, but it's traceroute on everything else. It's kind of an abbreviation there. But the point is, these tools are there for you. They will help you troubleshoot network connections between all of these different hosts in the network, and they're all very easy to use. Let's take a look at some of them now. Now, the first tool we'll look at is the netstat tool. And again, you'll find this on Windows and Linux, and it's very easy to run. It has several switches, as we will see. We've got a lot of different switches here, and it can give us a lot of information based upon the switches we want. Let's do something that's fairly common though. Let's do a netstat-an. And what this does is it gives us protocols broken out by what is running on the box, TCP and UDP. Notice the TCP4 means TCP under IPv4. TCP6 means IP6. And we've got UDP also. We also show the connections that are going out of the box, the different connections to different addresses. Right now we don't have any connections going right now, and there are some protocols that are in a state of listen, meaning that we're listening on certain protocols for incoming connections. We've got a lot of information here, and when you're doing network analysis and troubleshooting, this can actually help you out. Let's say on a Windows box in particular, if your box is slowing down and you suspect you may have some malware or something, you may do a netstat and see that your computer's consistently connecting to an IP address on the internet that you're not aware of, and that might be taking up a lot of your bandwidth, so that might help you out. On BSD, you don't have that problem so much, but you still may want to look at your connections and see who's connecting to your computer and how and when. Another tool we'll look at is dig, and dig basically replaces the deprecated NSLOOKUP. If you've ever used NSLOOKUP, it's kind of gone by the wayside. It's not really supported anymore. It's still there in a lot of instances, but it's not really supported. And dig basically does the same thing. Let's do dig.www.vtc.com, and we'll get some information from the DNS servers that handle vtc.com. And that's basically what dig does. It gives us DNS, domain name service information on a domain. Another command that's useful for getting network information is the arp command. It's actually very easy to use. In fact, if you just type in arp, you'll get a list of all the options that are available to you. The one we really care about is arp-a, because that gives us the table, the arp cache, some people call it, of IP addresses that have been resolved to MAC addresses. So the MAC address, as you may know, is the hardware address on the network card of the machine you're communicating with, and your computer keeps a table that matches MAC addresses to IP addresses, and this information is necessary for the computer to communicate on the network. One thing that ARP is useful for is to troubleshoot connection problems, intermittent connection problems where you can't quite pin down why something is not communicating, and it may be because of a failure to resolve the MAC address to the IP address using ARP. Now, yet another command I'm sure you're probably familiar with is the ping command. The ping command basically is used for simple connectivity troubleshooting. For example, you can ping your default gateway, or you can ping an address on the internet, and the only thing that happens is your computer sends a series of ICMP protocol packets to that computer, and the computer replies back with answers. Let's ping www.vtc.com, and we're getting an answer back. And unlike Windows, which defaults to 4 pings, Unix and Linux will ping forever until you tell it to quit. You can just press Control-C and it will stop. And basically it tells us that we've got a really good connection going out. We've sent 12 packets out and we got 12 replies back. If we didn't get any replies back, then we may have to start troubleshooting connectivity issues. But ping again is one of those universal commands that works on Windows, Unix, and Linux. Yet another command we'll discuss is the traceroute command. And the traceroute command basically uses UDP by default, but it can use ICMP also. It basically traces a path to the destination address that you're trying to get to. For example, if we were trying to get to vtc.com and we're having intermittent connection problems, we could use traceroute to go along the line and find out kind of where the problem is or how far out we're getting, and then narrow the troubleshooting effort down to that point. Basically, you type in traceroute, and then the domain name or whatever you're trying to get to. In this case, we could say vtc.com again, and it's going to basically take out and trace all over these different connections till it gets out in the internet and to the final connections where vtc.com has their services. This can take a little while. In fact, we're not going to let this finish simply because it does take a while sometimes. And as you can see, it's traced all the way up to hop number 15, and then it's starting to either time out or we're starting to get connection issues. That could be one possibility. The other possibility is the devices such as the routers or firewalls that we're going through may be programmed for security reasons not to return ICMP responses. So we would not get responses to our pings from those boxes. In some cases they would totally block those pings. In some cases they would simply pass them on, but they wouldn't respond to them. And that seems to be what's happening here, because obviously we pinged VTC.com a moment ago, so we know that it's up. We know that there's no connection problems. Probably what we're hitting here is several devices that are programmed to not return ICMP responses. So that's a security measure. It's actually a good security measure that a lot of companies and networks take. So we're going to go ahead and kill the trace route right here because it can take a while when it runs into this. But we've talked about just a few of the tools, and there are plenty of other ones out there, by the way. Some of them are GUI tools, great GUI tools, but we've only covered just a few of the tools that you can use when you are managing networks, troubleshooting connectivity problems, and just generally getting information on your network and doing network administration. And that goes hand in hand with your BSD, Unix, and other forms of Unix administration. That's why we consider networking basically a system administration essential. You need to know networking in order to fully administer a Unix box. So we've covered just a few of those tools, and there are plenty of other ones out there.